Hello student, now let us start unit 4 electromagnetism 4.2 concept of magnetic field. Now what is magnetic field? Magnetic field is a region in which magnetic force is exerted on another magnet. So magnetic field is region or space between the magnet force. If take two magnets either the same sign, that means south or north, or in different signs, that is north and south, if the force between these magnets either repulsive or attractive. If repulsive force, the north or south, the force between these two magnets repulsive force. So the region or space between this force is what you call magnetic field. Or if we take unlike or two different magnets like north south poles, if these two magnets, a force is attractive force, so the space or the region is between this force what you call magnetic field. So magnetic field is in general region or space between two magnet force. So magnetic force is like this. Or in other definition, magnetic fields are caused by the motion of charges. Not without motion of charge cannot create magnetic field, but it creates or caused the motion of charges, or due to the interaction of permanent magnets, not temporary magnet, but the interaction of permanent magnets or magnetic poles. Poles means the end of the magnet, or the end point of the magnet is what you call poles. So magnetic fields are not only produced by metal magnets. In other words, electric current will cause the magnetic field. So electric current will cause a compass needle to deflect. An electric current gives rise to magnetic field. Electric current rise to magnetic field. If there is no electric current, there is no magnetic field at all. So the interaction between magnet and electric current is increase the magnetic fields. In general, magnetic field is a region. Now let us see page on your exercise book, page 126, figure 4.10. So the north pole and the south pole, these two poles attract, or the force between these different poles are attractive force. So the region or the space is what you call magnetic field. The other, what is the properties of magnet or magnets? Now first we can define what is magnet. Magnet is a substance that attracts magnetic substance, not non-magnetic substance, but it attracts only magnetic substance. So what is the properties of magnet? Now there are different properties of magnets. The first one, magnet attract iron or magnetic substance, and it has always two poles. That means the north and the south pole. The second one, freely suspended magnet always stay north and south pole, because it has two poles every magnet, then the north and the south pole. Now the third one, every magnet has north pole and south pole. The end of magnet that point to geographical north is called north pole, and the other end of the magnet points to the geographic south is called south pole of the magnet. So the north and south pole. The fourth one, if you break a magnet, each half of the broken magnet becomes a complete magnet on its own, because it exists always in pair. Magnetic poles always exist in pair. If we break a magnet, then each half of the broken magnet becomes a complete magnet on its own. That means it has north pole and south pole. So magnetic poles exist in pair. The fifth one, like poles repel. That means like pole means the north pole repel each other and south pole repel each other, and unlike poles attract each other. Unlike pole means north south attract each other, or south north attract each other. The sixth one, magnet creates magnetism in magnetic material by induction. So these are the properties of magnet, or some characteristics of magnets. Now the other, magnetic lines of force. What is a magnetic lines of force? Magnetic lines of force are the imaginary lines in a magnetic field, are those image lines which continuously represent the direction of the magnetic field. The direction of the magnetic field. If the magnetic field lines are always germinate from the north pole and terminate the south pole, so the magnetic fields are image lines which continuously represent the direction of the magnetic field from the north pole to the south pole out of the magnet, and from the south pole to the north pole inside the magnet. So magnetic field lines or magnetic force lines or magnetic lines of force represent the direction of the magnetic field. Now some properties or some characteristics of magnetic lines of force. There are different characteristics or properties. The first one, the magnetic lines of force always generate from the north pole and following a curved path enter the south pole outside of the magnet and back, or reach back the north pole moving inside the magnet. The magnetic lines of force always generate from the north pole and terminate to the south pole outside the magnet and enter the south, then reach back the north pole moving inside the magnet to reach the north pole inside the magnet. Now the second one, two lines of the force never cross each other or never intersect each other because it parallel or it pass away parallel lines. There is no intersect or there is no cross one field lines to the other field lines. The third one, near the magnet poles where the field is stronger, the field lines closer to each other, then the magnetic field strong, and the field lines are far between the distance, then the magnetic field is weak. So the magnetic field lines determine the strength of the magnetic field. Now the next lesson, magnetic field lines around a current carrying wire. A current is carrying wire or a conductor. So what is the magnetic field around this? Magnetic fields are not only produced metal magnets. Magnetic fields are not produced only produced metal magnets. So an electric current will cause a compass needle to deflect. So there is a current, or an electric current give rise to magnetic field. If there is no electric current, there is no magnetic fields produced by only metal magnets. So the interaction between the magnet and the current is what you call magnetic field. So field is a region. Now, how to determine the direction of the electric current and the direction of the magnetic field? The magnetic field lines around a current carrying wire. So the wire is carrying current or conductor. Now, the first rule is right hand rule. So right hand rule is determine the direction of the magnetic field and the direction of the conventional current. How to determine the direction of magnetic current and the direction of electric current? Now, a way to predict the direction of the current and the direction of magnetic field: take your right hand, not left hand, and hold the wire with your thumb going the direction of the conventional current. So the thumb is indicate the direction of the electric current or conventional current, and your fingers round the wire is indicate the field lines go. So the thumb indicates the direction of the conventional current, and the other fingers encircle is indicate the direction of the field lines. So right hand rule is a way to predict the direction of current and direction of magnetic field. Now the other lesson, magnetic field strength at a point due to current carrying wire. Now the magnitude or the strength of the magnetic field, which is given by the symbol B, produced by a current carrying wire, depends on three factors. The first one, the force. The second, the current flowing through the wire. And the third, the length of the wire. So the strength of the magnetic field is determined by the force, the electric current, and the length of the wire. Now by this show the formula: force or magnetic force is equivalent to magnetic field strength multiplied by current flowing through the wire multiplied by length of wire. Now force symbolically F, and magnetic field strength B multiplied by current flowing through the wire I multiplied by length of the wire L. So magnetic force is equivalent to or equal to magnetic field strength multiplied by electric current multiplied by length. Now how to solve the magnetic field? Dividing both sides by electric current multiplied by length. Now force divided by electric current times length, and magnetic field divided by electric current times length. So current by current cancel out, length by length cancel out. What remains? Magnetic field. So magnetic field strength is equal to magnetic force divided by current times length. Now the SI unit of magnetic field strength is Tesla. 1 Tesla is equivalent to 1 Newton, the SI unit of force, divided by 1 ampere, the SI unit of current, times meter, the SI unit of length. So 1 Tesla is equivalent to 1 Newton per ampere times meter. So Tesla is the SI unit of magnetic field strength. Now let us see an example. Calculate the magnetic field strength when a current of 4 ampere flows in a wire is 2 meters long and produces a force of 8 Newton. Now given current 4 ampere, length 2 meter, and magnetic force 8 Newton. These all are given. Now what is required? Magnetic field strength, or B. Now force 8 Newton, length 2 meter, current 4 ampere. Now required magnetic field. Now from the above formula, magnetic field is equal to force divided by current times length. So force 8 Newton divided by length 2 meter times current 4 ampere. So 4 times 2, 8. Now 8 Newton divided by 8 ampere times meter, 1. So magnetic field strength is equal to 1 Tesla. It indicates Tesla. So magnetic field 1 Tesla. Student, if you have any doubt, any question, you can ask. Now magnetic field of solenoid.